Thank you. Hi, everyone. I have been giving versions of this talk now for close to a decade. And one of the things that I've always started these talks doing is asking this question, which is on a scale of 1 to 5, how concerned or alarmed are you about climate change and the wider ecological crisis, if you want? And I do this by a show of hands, so if you go through this with me, raise your hand when we get to the right level. Is it 1, not bothered, 2, mildly concerned, 3, concerned, 4, very concerned, or 5, alarmed? All right, that's the correct answer. But the thing is, and this is what's really interesting, is like, when I first started doing this 10 years ago, I think most people would have perhaps been about 3, right? And that was the regular response that I'd get. And as I've done this more recently, it is mostly 4 and 5. That's been a real shift in society in terms of our awareness, and I think the popular awareness of just the severity of where this is at. And so in some sense, this talk, or part of this talk, is now perhaps superfluous. I'm going to just be telling you something that you already feel and know. But what I'm going to try and do is explain, again, why it is that this is so serious. And I would invite you, if you already feel like you know this, to try and think about the way in which I'm telling this story and why I'm drawing attention to certain facts and how you could perhaps incorporate that yourself to help inform other people, and to try and use this as a learning exercise. I would also just like to point out that, as Rob said, I'm speaking here tonight both as a scientist, or formerly as a scientist. I don't do research anymore, actually, as of a few years, because now I'm a climate justice campaigner. And I've made that transition myself. And so I want you to be aware that as I'm talking, I am talking to you in both of those roles tonight. And I'm bringing my own values and my own perspectives to the solutions that I'm putting forwards. And it's fine if people disagree with those. But the first half of the talk is really about the science as I see it. And that is, to the best of my knowledge, our scientific understanding. And I've got resources and references that I can share with you if you want to know more about where any of that is coming from. Climate change as a phenomenon has been known about since the 19th century, or global warming. It is the phenomenon of the greenhouse effect, whereby atmospheric gases, greenhouse gases, such as carbon dioxide, methane, water vapor, trap heat from the sun and warm the planet. And if there wasn't this effect, then there wouldn't be life on Earth. We would be a frozen ball of rock moving around through space. But there are these gases, and that they have this effect, and therefore the temperature of the planet is such that there can be liquid water on the surface of the planet, and therefore life. But one of those greenhouse gases, a really key greenhouse gas, is carbon dioxide. And carbon dioxide is produced through the burning of fossil fuels. And we have been increasing the amount of carbon dioxide by a substantial amount over the course of the last 200 years since the Industrial Revolution started. In particular, carbon dioxide levels have now increased by about 40% in that time. And they are, as you would expect, causing the temperature of the planet to rise. And we can see that in a number of different ways, including thermometer records, but also in terms of changes in the physical landscape, melting of glaciers, and warming of oceans, movements of species around the globe in response to those warmings. We can trace the changes in carbon dioxide through time over vast periods of time. So this is looking at the last 400,000 years, and we can get this information from gas bubbles trapped in frozen ice, in ice sheets in Antarctica and in Greenland, which we can drill down and draw out cores with all the layers of ice from each year going back all that period of time. And when you do that, what you find is that the levels of CO2 have fluctuated in the atmosphere over time in this zigzag pattern. These are the ice ages. So here we've got interglacials, and here it cools down until you get to a maximum glacial period where the ice sheets cover large parts of the surface of the Earth. We can also, by analysing the gas bubbles and the ice in which they're formed, calculate what the temperature of the planet was at the time. It's some clever chemistry, but we can do it. And when you do that, you can see just how closely the temperature tracks with the changes in CO2. The two things are tightly coupled. And so we know that CO2 is a really powerful driver of global temperature, such that it can make huge transformations to the Earth's surface in terms of changes in the ice sheets and sea levels as a result. So there's a couple of things to notice about this graph. So firstly, what's happened to CO2 in the last short period of time? That's since we've started burning fossil fuels. It's completely outside the bounds of the last 400,000 years, and we actually know it goes back much further than that. It's probably the highest it's been in at least 3 million years now, which is to say longer than the whole of time that humanity has existed on this planet as Homo sapiens. We also can see here this unusually warm period of the Holocene. This is the last 10,000 years. This is the whole of human civilization has happened in that period of time. This period of unusual climatic stability, which allowed us to predict where the rains were going to fall, how hard they were going to fall, and where the sea levels were going to be, because during that period of time they were stable. And so that stability allowed us to develop agriculture. It allowed us to build settlements around ports and to trade across oceans, right? And the third thing I want you to take away from this is just the temperature difference between these ice ages at a global average was about 4 degrees, 4.5 degrees. So I grew up here in Snowdonia. This valley is the Ogwen Valley. My parents' house is just down here, and this is up on top of Penarolo Wen. And so at the height of the last glacial maximum, instead of having this view looking out across the valley, you would have seen this. An ice sheet half a mile thick with just the peaks of those mountains sticking out amongst it, with no ability to have agriculture or civilization there. The temperature difference between that period of time and pre-industrial temperatures as a global average was just 4.5 degrees. If we carry on warming at the rate we are, then by the end of this century, the total average temperature of the planet will be 4.5 degrees warmer than pre-industrial times. So we're making that big a change to the Earth's environment in an incredibly short amount of time. So what we're seeing is this warming. This is from NASA, and it's a reconstruction of the temperature record over the last 140 years. And you can see over time, the temperature of the planet is increasing and getting hotter and hotter and hotter. And in particular, it's happening in the Arctic, where you get this phenomenon of Arctic amplification. It's warming in the Arctic about twice the rate of everywhere else, which is partly why ecologists like myself go up there to study the impacts there, because they're just so dramatic. But the other thing that you can see from that video is the way that you get the fluctuations still. You still get weather over time. So sometimes one area is warmer or cooler than another. But over time, what you see is steady warming. And that is why I would say that we're in a climate emergency. But don't just take my word for that, okay? This is Ban Ki-moon. He was the former head of the United Nations. And he said about a decade ago now that this is an emergency. And for emergency situations, we need emergency action. And he's saying that as a politician because that's what the scientists are all saying. And this is Professor James Hansen. He was the former director of the NASA's Goddard Institute for Space Studies. And he's saying we are in a planetary emergency. Lonnie Thompson, he's one of the scientists who takes these ice cores I was telling you about from Antarctica and the other glaciers. He's saying that virtually all of us as scientists are now convinced that global warming poses a clear and present danger to civilization. This is the same video as I showed you before, that NASA video, but this is that plotted as a graph, and you can see again the warming that we've seen. We've seen about 1 degree Celsius so far, and we're already seeing the impacts of that. If we carry on warming, that's the 1 degree that we've seen so far here in the black line, and this is then our choice that we have before us. Do we continue warming along this trajectory to stabilize the temperature of the planet at about 2 degrees? Or do we follow this one and warm the planet up to 4 or more degrees by the end of the century? Now, there is uncertainty in our climate model scenarios. We cannot be exactly precise as to what the temperature will be depending on which of these pathways we follow in terms of how much fossil fuels we burn. But what we can say with absolute certainty is that if we phase out fossil fuels, the warming that we should see will be far less than if we carry on burning them. And just to put that 4 degrees in the context of the last 10,000 years, this is what it looks like. It's like driving into a brick wall. But it's not just the average temperatures that we need to be concerned about. It's the way in which changes in those averages changes the extremes. And so this graph is a bell curve. It shows you the distribution of temperatures that we see at any given period of time. And you can see here where it's a third of the time it's cooler than average, a third of the time it's about average, and then a third of the time it's warmer than average. That's what this is showing you. And now I'm going to show you how that distribution has changed over the last 50 years or so. So this is the 1950s through 1960s, 60s through 70s, 70s through 80s, 80s through 90s, 90s through 2000s, and 2000s into 2010s. And so what we're seeing now is that we're still getting occasionally these extremely cold days, but we're getting far, far more of these incredibly hot days. To the point where we're seeing these extremes that we would never have seen before. They just could not have happened. And so we're all seeing this on the news all the time, right? We've just experienced the hottest summer day the UK has ever experienced. We've had heat waves breaking records in Europe by several degrees, which again, shouldn't happen. We're seeing record heat waves in the middle of winter in February. You know? We're seeing this all around us. So this hot extreme, which used to cover less than 1% of the Earth's surface during the 1950s, is now about 10% of the land area. So it's already increased tenfold. And that's just with 1 degree of warming. If we were to warm the planet by 4 degrees, what would that do to these extremes? So this is some work done by the Met Office at the Hadley Centre down in Exeter, some of the best climate scientists in the country. And this is what they've said. So for 4 degrees Celsius of global warming, then on the hottest of the hottest days in China, they would be 6 to 8 degrees hotter than the hottest days they've currently experienced. In Europe, they would be 8 to 10 degrees hotter than the hottest days we've currently experienced. And in New York, it might be as much as 10 to 12 degrees hotter. And you can just imagine what that then does to the infrastructure of a city. People suffering from heat stroke, going to hospital where the air conditioning is no longer able to cool them in the hospitals, and they're suffering from heat stroke. And the doctors themselves are suffering from heat stroke. And then you've got the fact that food spoils everywhere in the markets, starts to rot. You've got fields where the food is wilting. You can't get it to where it needs to be. We saw again this summer just how disrupted the rail network is in the UK by warming as the tracks risk buckling, and then you have to slow the trains down, and that then changes all the timings between all the transport systems. There's an infinite number of these kind of repercussions that we see if we stop to think about them, whether or not it's bacteria growing in water pipes, or it's to do with the way in which our electricity pylons start to kind of overheat at high temperatures, and that causes then cascading failures through the power system. And the social systems that we rely on will be stressed by these extremes. So this is showing you, for example, the number of extremely hot days and nights that cause heat stress. And so this is compared to a base period of the 60s to the 90s. And they're saying this is what it's going to look like in the 2020s, 2030s, and this is what it's going to look like in the 2070s, 2080s. And what it's showing you is the number of nights a year where the temperatures are above 20 degrees at night or hotter than 35 degrees during the day. So these are extremely stressful temperatures for the human body. And what you can see is that already by the end of the century, then you're going to be having over 50 days a year like that throughout much of the Mediterranean. They'll be as hot as currently parts of North Africa are today. We saw the consequence of these kind of extreme heats in Europe back in 2003. So I was a child. Oh, we saw them again this summer. But I was a child camping in Europe that summer, and I just remember it as being horrid because it was so hot in the tent that we had to kind of dash out of the tent to try and jump in the swimming pools to cool down. But even that wouldn't cool you down because the temperature of the pool was too hot. And so we had to spend our summers running around between supermarkets to use their air conditioning. It wasn't much fun. But at least we could do that. And unfortunately, tens of thousands of people across Europe died that summer as a result of heat death. And we know that now, looking back after the fact, that it was the most deadly natural disaster that Europe has seen. 70,000 people died across Europe that summer because of the heat. They were mostly elderly or younger people, infants. This is the heat wave that we saw in 2003. It was completely exceptional. Nothing like that had been seen before. But by 2040, that will be an average summer. And by 2060, almost every summer will be hotter than that. That's the future that we're heading for. We can do that same analysis not just for one country and like France, but for the whole globe, and say which year will every single year be hotter than the hottest year they've ever had on record in that country. And we can see that in the tropics, that date arrives much sooner. So that's in the 2020s to 2030s. But by the 2040s or so, even the subtropics will be experiencing every single year as hotter than the hottest year we've ever seen on record so far to date. These graphs show what that means for drought, and is a measure known as the Palmer Drought Severity Index, which measures how dry soils are. You can imagine basically that the Dust Bowl back in the 1960s was, 1930s in the US, which was about that dry here as for scale. But you can see that most of the Midwest, large parts of the Mediterranean will become that arid by the 2060s and going much further beyond into the South America and the tropics there, and also in large parts of Central America, right? Some of these are some of our major grain-producing areas of the world. So the Midwest is the Corn Belt of the United States. You've got Ukraine and the corn harvest of Russia, and likewise parts of China down here as well. That's where the world gets its foods from. And yet we're going to be so dry in those areas that it's equivalent to being in the Dust Bowl. And we've already seen, again, increasingly those kind of extreme weather events taking their toll on harvest. So this is from 2012 in the United States, when they had a record-breaking drought in large parts of the Midwest, and corn harvests that year were reduced by 30 to 40%. This is another drought in the United States that happened between 2011 and 2015 in California. Again, this was completely exceptional. So you can see exceptional drought covered most of the Central Valley, and it just carried on persisting and persisting. So this is what that looked like. So this is the winter snowpack in Yosemite, 2012, 13, 14, and 15. And that had a huge consequence then on the reservoirs in California, because there wasn't any water replenishing those reservoirs, and it was really hot and therefore evaporating all the water that was there. The scientists who study that from Stanford said that the risk of this severe drought in California has already increased due to exceptionally warm conditions induced by anthropogenic global warming. In fact, they said that that was about 5 times more likely to have happened because of climate change already. But California, again, is one of the major food-producing areas of the United States. It's responsible for growing 99% of all the almonds in the US, 99% of all walnuts, pistachios, 95% of all broccoli, strawberries, 90% of all grapes. You know, this is where civilization is getting its nutrients from, right? That we're completely reliant on these agricultural systems. This is an orange grove in California where the grower had to make a decision as to which part of his crop he was going to water and irrigate, because he could not afford to keep it all alive. And so this is them driving a bulldozer, scrubbing rows after rows of orange groves. So this is again showing us that choice that we have between a low emissions scenario where we stabilize the temperature of the planet versus one that we continue warming to the end of the century. And in both of them, the United States is going to get significantly drier. But this one, it's going to start turning into a desert. And this is going to be happening all around the world. So again, we're seeing this happening again, increasingly. Major cities, Sao Paulo, the largest city in South America, almost had to be evacuated just a few years ago because it ran out of water. This is connected as well partly to the deforestation of the Amazon and the fact that as you chop down trees, they don't draw up as much water into the atmosphere, and therefore you basically are stopping the rivers of water that are moving through the air from the Amazon forest over South America and then replenishing these reservoirs. Same thing in Cape Town. Almost was evacuated just a couple of years ago, where a city residents were having to queue for water from standpipes, and they were watching down to what they were calling day zero, when there would not even be any water left in those taps. Luckily, the rains came, but how much longer do we need to wait before that is not a possibility? And again, in India now, just again, a couple of years ago, we saw 330 million people were affected by drought. And just this year, we heard that Chennai, again, as one of the largest cities in India, almost had to be evacuated because the monsoon rains were so delayed in arriving. In 2010, another one of these deadly heat waves struck Russia. It's estimated that, again, tens of thousands of people died in those heat waves, but another consequence of them was that their grain harvests set on fire. 40% of their harvest burnt down, and as a result, Russia put a ban on the export of grain from Russia. And that then had huge implications for the food markets. And so this is what's known as the food price index. And what we saw is, following this embargo in 2010, there was a spike in the price of food. There was another one here in 2008, and that was largely as a result of a policy introduced in Europe and the US to switch to allowing biofuels. And so that kind of linked together the grain and the fuel markets. And you got a spike then as well. And what this shows you, as these dashed lines, are incidents of food rioting around the world. And the numbers there show you the number of people who died as a consequence of those riots. But what you can see, particularly after this one in 2010, is you've got names like Tunisia, Libya, Egypt, Yemen, places that we came to associate with the Arab Spring. And at the time, Egypt was the largest grain importer in the world. And so when this food price spike happened, large numbers of people who had been on the breadline as it was could no longer afford to feed themselves and their families. And they went out on the streets and they were chanting for food, bread, freedom, and social justice. But bread was their first demand. Okay? These things are all connected. Another one of the countries affected by the Arab Spring was Syria, of course. Now, I'm really not saying that the civil war in Syria was a direct result of climate change, but it was a factor. And this is the way in which it was a factor. Because in 2006 to 2010 and 11, Syria experienced its worst drought on record. Its worst drought, at least in the last 900 years that we can tell through records. In particular, the northeast of the country dried out really severely, and they had to abandon large parts of agricultural land. Crops failed repeatedly year after year. They had to cull 80% of the livestock herds that they had in those areas, and young men left those villages and those towns to go to the cities to look for work to support their families. But there they were met again by overcrowding, not any resources, and then following that, this price spike in food that they could no longer afford to care for themselves. So this is showing you that drought is probably linked to climate change, right? So this century-long observed trends in precipitation, temperature, and sea level pressure, supported by climate model results, strongly suggest that anthropogenic forcing has made the occurrence of a 3-year drought as severe as that of 2007 to 2010, 2 to 3 times more likely than by natural variability alone. We know that this was from a cable leaked through WikiLeaks from the US Embassy back to Washington at the time, and they said that Syria's UN Food and Agriculture representative told us that the Syrian Minister for Agriculture stated publicly that economic and social fallout from the drought was beyond our capacity as a country to deal with. This social destruction would lead to political instability. So this was in 2008, 3 years before the civil war broke out. And they asked at that time for food aid from the rest of the world, and none was given. So even senior figures in the humanitarian sector, such as the head of the Red Cross, says that it's obvious that some of the violence that we are observing is directly linked to climate change. And so for that reason, and for many others, the World Health Organization has said that climate change will affect in profoundly adverse ways some of the most fundamental determinants of health. We're seeing all sorts of impacts, not just heat, but we're also seeing record flooding, we're seeing record wildfires, we're seeing record-breaking hurricanes and typhoons, and there's another Category 5 hurricane about to strike Bermuda today, and then go on to Florida probably later in the week. We're seeing that all of these things are becoming far more common now, right? So this is some data provided by the World Meteorological Organization, where they collect the incidence of these extreme weather events, and these are from different categories, so floods, storms, droughts, extreme temperatures, wildfires. But what we can see is that they're all increasing, right? They're increasing exponentially as we're warming this planet. And everything is actually happening often, a lot of these things are happening faster than science was expecting. So this is Professor John Holdren. He was a former presidential science advisor to Barack Obama. He was also the former president of the American Association Academy for Arts and Science. And he says that everything that is expected to result from global climate change driven by greenhouse gas emissions is not only happening, but is happening faster than anybody expected. This is just from 2017, but just showing you kind of all of these are examples of record-breaking flooding happening month after month. So California in February, Peru in March, Sri Lanka in May, China in June, Mumbai in India in August, Houston that was the record-breaking hurricane that struck there, Puerto Rico shortly afterwards, Ottawa in Canada, and then Greece. And we've seen it here in Somerset as well, just in a few years ago, right? This is from 2015, when we had record-breaking winter rains. And I was visiting my parents here back at the time. We had about a metre of rainfall that December, which is more than we normally have in the whole year. And we had flooding on all of the major roads, including the two main roads that separated the rest of the UK from Holyhead and the connection to Ireland. So a lot of people were stranded as a result of that. This is Dame Professor Julia Slingo. She was the former chief scientist at the UK Met Office, and she was remarking on these floods at the time and saying that all the evidence suggests that there is a link to climate change. There is no evidence to cancel the basic premise that a warmer world will lead to more intense daily and hourly rain events. We're seeing glaciers disappearing all over the world. As temperatures rise, ice melts. And so this is in Alaska in 1941, and the same photo in 2004. This is in Argentina in 1928, and again in 2004. And this is in the Himalayas in 1921 and in 2009. It's predicted that at least a third of the glaciers will be lost from the Himalayas this century, even if we stabilize at 2 degrees. If we continue warming beyond that, as much as 2/3, if not more, is vulnerable to being lost. These are the water towers of the world. They keep water running into some of the major rivers throughout the year, allowing for the irrigation of crops during dry months in the summer. So this is La Paz in Bolivia, and you can see this is the highest city in the world. Pretty much 800,000 people live here, and in the background you can see the glacier which feeds this city. That glacier is shrinking really rapidly and will be gone within the next few decades. This is the Indus River that runs through Pakistan. If this river wasn't there, Pakistan would be a desert. It's fed by 5 different tributaries, rivers, which all come from the Himalayas, 4 of which go through Indian Kashmir. And India claims supremacy on all the water rights in those rivers. These kind of situations are potentially a hotbed for conflict and for dispute. We also have melting of ice, not just on glaciers, but also sea ice. And so this is showing you the Arctic, where the sea ice is normally very white and reflective, and it would reflect a lot of the heat that strikes it back into space. But that's starting to melt too, and when it melts, it becomes ocean water, which is much darker, and that then absorbs much of the light and heat, and that leads to more warming. And you get partly that's causing that amplification effect in the Arctic, where the Arctic's warming up faster and faster because it's losing more and more of its ice. So this is showing you what the ice extent used to look like back in the 1970s when we first put satellites up there to monitor it. And this is what it looked like in 2012, which is the record lowest extent so far. This year was the second record lowest extent. And it's lost about half of its area in that period of time. And if you look at the volume, which is including the thickness as well as the area, then it's more like 70% of all of the ice has gone at the end of summer. It still grows back in winter, but then it melts again more the next year. This is Mark Cerise. He's a director of the National Snow and Ice Data Center, one of the leading experts on ice. And he's saying that we may lose the summer ice cover as early as 2030. That means it will all melt out at the end of summer. This in itself is much earlier than projections from nearly all climate model simulations. When the sea ice melts, it doesn't affect sea level rise because that ice is already floating on top of the oceans. But we're also seeing melting of land ice, the ice sheets, in Greenland and in Antarctica. And you can see that both of those are now losing substantial amounts of ice and at an accelerating rate. Again, nobody expected the ice sheets to be losing so much mass so quickly. So we are seeing an accelerating rate of sea level rise. We've seen about 20 centimeters of sea level rise throughout the 21st century. We're going to see far more than that in the current century. So these are projections from the IPCC. So this is if we stabilize the temperature of the planet at 2 degrees. And this is if we continued warming along a high emissions trajectory. And we can see that we're expecting probably in the region of about 1 meter sea level rise. Most of the, likely this is an underestimate. So this doesn't properly take into account the accelerating feedbacks that we're seeing in Antarctica and the fact that the ice sheets there seem to be much more unstable than had previously been thought. 1 meter of sea level rise could raise the frequency of severe flooding in New York City from once per century to once every 3 years. And we've seen what once in a century flooding in New York looks like when Hurricane Sandy struck there in 2012. So this is the metro system completely flooded. This is neighborhoods in Queens that were knocked down by the storm surge. And this is the pier in Cody Island. But it's not just cities like New York and many other cities around the world, so Shanghai, Tokyo, Rotterdam, Miami, which are all incredibly exposed to this. But it's whole countries, whole deltas, like here in Bangladesh, where a 1 meter sea level rise would displace on the order of 15 million people and inundate 17,000 square kilometers of land. The question is, where are those people going to go? And at the moment, India has built a fence around its entire border with Bangladesh and is now patrolling that with armed guards with an order of shoot to kill anyone who tries to cross. But I want to put this photo in because when you're looking at those kind of maps and those projections, it can become very easy to just disconnect from what it means. But this is what it means. It means people losing their homes and losing their livelihoods right before their eyes. And this is already happening around the world today. We're seeing huge impacts on biodiversity. As Rob was mentioning, there are other impacts there that are also threatening nature and the ecosystems that we depend upon. But climate change is one of the leading drivers of biodiversity loss now. And this is showing you the Great Barrier Reef in Australia with a plane flying over it. And that's the shadow there. And what you can see here is that this reef is white. And the reason it's white is because it's undergone a phenomenon known as bleaching. So this is a normal coral. It's a symbiotic relationship between an animal, the coral, and an algae that lives inside the coral and gives it energy. But if the temperature gets too hot, that relationship breaks down and the coral expels the algae, but then it starts to starve. And if it goes on for too long, the corals starve to death. And so this is showing you, in 2016, the areas where there was an alert put out for all the coral reefs in those areas because the temperatures there were spiking beyond what the corals could cope with. And what we saw in Australia was that you had these mass bleaching events where half the corals on the Great Barrier Reef died in just 2 summers. And this is like the Amazon of the oceans, right? This is one of the most biodiverse ecosystems in the world vanishing before our eyes. And the harsh reality is that even if we stabilize temperatures at about 2 degrees, then the return frequency of these heat waves will be so regular that none of these corals will have a chance to recover. It's estimated that if we kept temperatures warming to 1.5 degrees temperature rise, we'd still lose about 90% of all coral reefs. So this is Professor Hugh Goldberg, who's director of the Global Climate Institute in the University of Queensland in Australia, who spent his whole life studying these reef systems. And he's saying, I think that 20 years from now, every summer will be too hot for corals. They will disappear as dominant members of tropical reef systems by 2040 to 2050. It's hard to argue it any other way. But it's not just corals, it's all sorts of biodiversity that are being affected by this. So what this map is showing you is the areas known as biodiversity hotspots in the red. So these are areas which hold the overwhelming majority of the Earth's species. And what you can see is that they're all mostly in the tropics, but it's the tropics that are going to reach those temperatures where every single year will be hotter than the hottest year on record the soonest. And that gives these creatures very little time to adapt and move out of those areas. And the thing that's really hard for me to convey in this kind of talk, because I'm having to go through each one of these things one after another, is that they will all be happening simultaneously. And they'll all be getting worse decade after decade until we do something about it. And that is why climate change has been described as the biggest human rights issue of the 21st century by the former UN High Commissioner for Human Rights, the greatest environmental threat that humanity has ever faced by Greenpeace, that it is the greatest global health threat of the 20th century by the leading medical journal, The Lancet, that it presents security challenges of a magnitude and a complexity that we have never seen before, according to the former NATO Secretary General, that it is the single greatest threat to sustainable development, according to the Secretary General of the UN, and that it is the greatest market failure that the world has ever seen, according to the UK's leading climate economist, Lord Nicholas Stern, who wrote a really influential report about this back in 2006 for the UK government. Climate change is not one of these things. It is all of these things, and all the interactions between them. And that is why this is a planetary emergency. And that is why world governments have got together to say we have to keep the temperature of the planet from warming beyond that 2-degree threshold. Because to warm the planet by more than that would just be far too dangerous. Now, there are going to be impacts below that. We're already seeing the impacts today. I was just showing you those impacts. But it's been decided that those impacts are acceptable risks. So again, quoting Professor John Holdren, he's saying, avoiding dangerous anthropogenic interference in the climate is in fact already unattainable, because today we are already experiencing dangerous anthropogenic influence. The real question now is whether or not we can still avoid catastrophic interference in the climate. So, as I said, the world governments have got together and agreed this in Paris in 2015, and they said that we have to keep the temperature of the planet below 2 degrees Celsius, and to pursue efforts to limit temperature rise to 1.5 degrees Celsius in the recognition that actually even that is too dangerous for level of warming. Also importantly, and I'll come back to this later in the talk, the agreement said that it will be implemented to reflect equity and on the principle of common but differentiated responsibilities between nations. But the crucial thing to understand is that time is of the essence. We have got no more time left to solve this problem because we have continued to delay for so long. And so if we want to reach that 2 degrees target with any certainty, if we peaked emissions in 2011, we could have come down along this green curve and have reduced emissions by 80% by 2050. We didn't peak the global emissions then. If we'd peaked in 2015, we'd have had to bring them down so that we'd got to zero by before 2050. We didn't peak emissions then either. If we wait until 2020 to peak emissions, we'll have to bring them down even faster and get to zero by 2040 as a globe. Because effectively, the temperature of the planet is going to be determined by the total amount of carbon emissions that we put out. And the longer we delay cutting emissions, the more emissions we put out in the meantime. And so to have the same chance of getting to zero, to stabilize at that temperature, we have to do even faster emissions cuts. So it's the cumulative emissions that matter. But in other words, that means that we have a budget. We have a carbon budget. And this rewrites the chronology of climate change. It's not about long-term future gradual changes that we have to make. It's about urgent and radical reductions in emissions that have to happen now. So some people might say, well, that's just too difficult. We're not going to be able to achieve those rates of emissions reductions. But then the question becomes, is aiming for 4 degrees Celsius any more realistic? So for a 4 degrees Celsius emissions would have to peak by with emissions peaking in 2020, we'd have to still reduce them at 3.5% a year. And that would then mean that we ended up with a 4 degrees Celsius world. That's the brutal logic of climate change. There's no way that we can get out from having a different future here. It's either going to be drastically different because we don't do anything and we end up to where we're headed, or it's going to be drastically different because we choose to change how we're doing things and respond to this challenge. There's a widespread belief that in the scientific community that a 4 degrees Celsius future is incompatible with an organized global community. It is likely to be beyond adaptation and is devastating to the majority of ecosystems and has a high probability of not being stable, which is to say it will probably lead to more warming beyond 4 degrees. Rachel Warren, who studies agricultural systems, has said that we already have observed impacts of climate change on agriculture, and we've assessed the amount of climate change that we can adapt to, and there is a lot that we can't adapt to even at 2 degrees Celsius. At 4 degrees Celsius, the impacts are very high, and we cannot adapt to them. And if we look at where we're currently headed on a global level, and add up all the pledges from all the world's governments at Paris and said, well, where does that take us? Well, then, if they carry out all their pledges, we would be heading to a temperature rise of at least probably about 3 degrees. They're currently not on track to meet their pledges, so we're heading to more like 3.3 to maybe as much as 4.5. So we're still on course currently to that 4 degrees future by the end of the century. So this is where we're going to take this pause for a second, and I'm just going to invite you to sit for a couple of minutes in silence and think not just intellectually about what I've just been telling you, but as Rob said, also to try and connect emotionally with what you've just heard. And then, so long as you're willing, we're going to ask you to share that with the person sat next to you. And the rest of this talk is going to be my answer to how I see the way in which we can find courage and carry on and accept the reality of the situation that we're in and still think about what we can do to take action and move forwards. And so here's some quotes from some other scientists who work on these problems. This is Leslie Hughes, who is a very eminent biologist, and she's saying every year our natural capital declines a bit more as we squander our heritage and rob our descendants. Matthew England is an oceanographer, and he's saying not dealing with it is selfish, short-sighted, narrow-minded, and obscene. It represents such a level of injustice as those that are going to be impacted are not playing a role in the decisions that are being made now. Shwana Murray, she's a climate scientist who studies these heat waves. She's saying, I'd like to think that we're not going to reach the projected 4 degrees of warming this century, because I can't even imagine what that would look like. 80 years is not that long, and unless we act soon, my 7-year-old daughter will probably have to live through that. We're trapped too. And so the rest of the talk, as I said, is trying to look at what we can do to move forwards. And because of that, it's far more my own personal take and opinion. But here we go. So this is a new report that came out this year by the Institute for Public Policy Research. And what they say is that when you look at this crisis, and it obviously is a crisis, what is the root cause of this? And in their view, it is that there has been a historical disregard of the environmental considerations in most areas of policy, and that has been a catastrophic mistake. It's just always been seen as superfluous, as something that we can get to as a luxury or when we have time or an interest. It's never seen as the priority. But of course, that's an illusion, right? Because as I've just been showing you, everything depends ultimately on the health of our environment. And so policy has not been able to address this problem yet. We have not even really tried to address this problem on a global scale yet. And so half of all the emissions that have ever been released have happened since 1988, which was the year that the IPCC was set up to help build a consensus for action scientifically, but also shortly afterwards the UNFCCC, the kind of international UN body that brings together all the world to take part in the climate negotiations. In fact, it's just continued going up and up every single year. And part of the reason for that is the huge misinformation campaign that has been waged by vested interests, in particular the big oil companies. They knew about this problem back in the 1970s. We know that because we can go into the archives of their records and actually bring out these documents that show, for example, in the 1970s that Exxon had it on their own files, and these were files that were seen by senior executives in the company, that there is no doubt that increases in fossil fuel usage and decreases in forest cover are aggravating the potential problem of increased CO2 in the atmosphere. They knew. And yet they did what the tobacco companies did when they were presented with the evidence that smoking was linked to lung cancer, and they hired PR firms to spin and mislead the public about the connections between those two things. In fact, it was the same PR companies, and in fact, even some of the same individuals in those companies who worked on both of these campaigns. We have as much scientific certainty that climate change is being caused by greenhouse gases as we have that smoking is caused by tobacco, and we've had that for decades. So why is it that so much there's been so much misinformation? It's because they knew that doubt was their product. They have been selling the public confusion and uncertainty. They didn't have to show that scientists were wrong. They had to just put a seed of doubt in enough people's minds that maybe the science isn't settled yet. Maybe we should just wait until we know more. And then we can carry on with our lives until we know more. We can carry on smoking cigarettes until we're sure, right? And that's unfortunately, that's part of the problem of human psychology. And they exploited that. And they exploited it to hold on to their record-making profits. So this is Frank Luntz. He is a Republican pollster in the United States, and he worked for the Bush's department when Bush's administration, and they were doing some polling on what the public thought about climate change. And he said at the time, and we know this because again it was leaked as a memo from the White House, that should the public come to believe that the scientific issues are settled, their views about global warming will change accordingly. Therefore, you need to continue to make the lack of scientific certainty a primary issue in the debate. They knew what they were doing, and they were bloody good at it. This is a network exposed through investigative journalists and environmental campaigners at Greenpeace, showing you these kind of talking heads who would appear on television and write columns in newspapers and so on and so forth. And they worked in these think tanks and institutes like the Cato Institute, the Heritage Foundation, the Competitive Enterprise Institute. And all these institutes got money from Exxon, right? There was a web of lies being spun around us to keep us in the dark. And scientists like myself have been out there trying to convey the scientific information, but we've been outgunned and outmatched, I would say, by experts and pros who are trained in PR and all the techniques that go along with that. And we've seen this in the British press for years. You know, even the BBC has been consistently bringing on climate skeptics onto their programs and giving this debate false balance. Here's the scientist, and here's someone who denies that this is happening, but we'll let you make up your mind who to listen to. You know, why climate change is not causing extreme weather, why climate change isn't happening anymore, right? Like, it's all nonsense, but that's what we're surrounded by in our media. And so that is a big part of it. We're not being told the truth. So why is it that the fossil fuel companies have spent so much time and in money and effort and resources into doing this? And I think this is part of the problem. So if we remember that I was saying we've got this carbon budget, there is only so much carbon we can afford to burn to stay below our temperature targets. That can be represented here by this bubble, right? There's only 560 billion tons of carbon that we could emit. I think this is going back a few years, but it's more or less that kind of amount. And that's all we can emit from now until 2100. And yet, already on their books, oil, coal, and gas companies have this much. It's 5 times more. So the question is, if we are to meet this target, we've got to leave most of the coal, oil, and gas available to us in the ground, unburned. And they know this too. And so that's why, like, you know, their profits, their business model is at stake, and their shareholders are demanding that they continue to extract those resources. This is common knowledge that most of these resources can't be burned, right? So this is Mark Carney, the governor of the Bank of England. He's saying, you know, if we're to meet 2 degrees Celsius of warming, then the vast majority of reserves are unburnable. And he's saying that this is a real threat to our economy as well, because this is an asset bubble that's building up here. We're either going to take action, in which case most of these companies are nowhere near as valuable as they say they are, or we continue not taking action and then have to deal with all the costs and consequences of climate change. But if you listen to what these companies are saying, then they predict increasing use and demand for fossil fuels going out throughout to mid-century, right? So this is BP saying global oil demand to grow into the 2040s. If this is ExxonMobil, ExxonMobil sees oil dominating energy mix to 2040s as retiring CEO Tillerson set to take on Secretary of State role. So he went on from Exxon to go and be Trump's first Secretary of State. So that's the future that they are seeing. That's the one that they are trying to head towards. That's the one that they're building all their infrastructure to take us to. And it's not just fossil fuel infrastructure in terms of the extraction of those resources, it's also all of the infrastructure that uses them. So every time we build a new power station that burns fossil fuels, every time we build a new pipeline, a new refinery, a new airport with planes that burn fossil fuels, right? Every piece of infrastructure as a society that we commission is locking us in to a future of continued emissions of carbon dioxide. And if we want to try and avoid that future, then we're going to have to start writing some of these things off and just shutting them down early. So this is a professor from the University of Oxford. He's an economist. He says, investors putting money into new carbon-emitting infrastructure need to ask hard questions about how long those assets will operate for and assess the risks of future shutdowns and write-offs. For policymakers who think of climate change as a long-term future issue, this should be a wake-up call. Whether we succeed or fail in containing warming to 2 degrees Celsius is determined by what we do now, not in future decades. So it's the same point I was making to you earlier. But this is what the CEO of Shell is saying. He's saying, if we are not careful, broader public support for the sector will wane. This is the biggest challenge we have at the moment as a company. The fact that societal acceptance of the energy system as we have it is just disappearing. Well, fantastic. But it terrifies me that he sees this as a problem and a threat and something to be fought. So this is Jonathan Rowson. He used to work for the Royal Society of Arts, and he wrote a really fascinating report on this for the Royal Society called The 7 Dimensions of Climate Change. And in that he says, the present that occurs now is shaped by how an imaginary future was acted upon in the past. Risk assessment does not just represent the future. In altering the behavior of the present, it also changes the future that ultimately elapses. And that's the point of me giving this talk today, right? I'm not trying to say that we're doomed and this is the future we have to head to. I'm saying it's the one that we will head to if we don't take action and change. And in effect, there's a battle of the imagination going on between us and these CEOs in the fossil fuel companies about what the future will look like. Will it look like one in which we continue burning more and more fossil fuels, in which case that's the one that we will build? Or do we imagine a future where we leave that behind and transition to a low-carbon society? So it's a battle of the imagination that is going on. And right now, I would say we're losing that battle. Because we cannot create what we can't imagine. This is an American poet, Lucille Clifton. So the rest of the talk is about trying to imagine what that better future might look like. And switching things around. So the question is, will we change? So here's my attempt at an answer. So pathways limiting global warming to 1.5 degrees Celsius would require rapid, far-reaching transitions in energy, land, urban and infrastructure, including transport and buildings and industrial systems. This is the Intergovernmental and Panel Climate Change most recent report, right? Far-reaching transitions. Okay, that's the kind of scale that we have to be thinking on. It's not going to be small things, okay? So we have to think in systems, okay? So this is a diagram of the UK's energy system. So these are all the kind of sources of fuel that we currently are importing, and this is what we currently use, and here's what's currently lost. I'm not asking you to know the details, but just, systems, right? This is our transport system in London, the Underground, right? Or a food production model of the system in the United States. And again, huge amounts of it is lost to waste because it's fed to livestock and things like that. So the actual amount that we grow is very little compared to what we actually consume. There's large inefficiencies in the way that the current systems operate. This is an attempt to display visually the governance system of the UK. This is particularly just looking at the healthcare system and how that's governed from central government through to the Department of Health and all the different regulating bodies and industries and overseers and the other parts of government in the Welsh Assembly and the Scottish Government. All of those things are part of a system of how we make decisions in this country. And of course, there is also our economy, our economic system. And this is a diagram from a fantastic book called Donut Economics by Kate Raworth, and in which she tries to relocate the economy within the Earth system and recognize that actually you have the Earth, and then within that there is a flow of energy and material which enters into societies, has uses for, and we distribute those uses through the economy. And that's both in terms of a market, but also allocation by the state, things that we share in common in the community, and also within the household and how decisions about who gets what happen there. So it's a much more holistic understanding of what the economy is. So if we were to then break down in the UK our emissions by sector of the economy, and then we can see that transport is responsible for about a quarter, as is currently energy supply. Business and industrial processes are responsible for about 17%. Residential, that's mostly heating, but also cooking as well. And then agriculture and food production, and then also waste management is another big sector. And then there's other things as well. So they're the kind of key sectors, and so that's what I'm going to focus on in this talk. But the kind of key point that I'm trying to convey here is that this is about systems change to stop climate change, right? It's not about tinkering around at the edges. It's not about what we're doing with our own individual lifestyles. It's about how do we run society together. And I think crucially, to make these transitions and solve these problems, we have to look for where there are tipping points in these systems, where really small gradual kind of changes can suddenly tip over and become a very rapid discontinuity and a shift in society. And that tipping point is that magic moment when an idea, trend, or social behavior crosses this threshold, tips, and then spreads like wildfire. And we've seen these throughout history. So I think I like this example a lot. I used to live in Edinburgh. And there's a story about Edinburgh that it used to be known as the Old Reekie. And the reason it used to be called that is because it stank. And back in the 1700s, there was a tourist going up to Edinburgh from London, Edmund Burt, and he wrote a letter back to his friends and colleagues. And in it, he described a kind of a story that had happened to him, where he'd arrived in Edinburgh, and he'd stepped into a pub to have a pint of ale, and the clock struck 9 o'clock, and then suddenly everybody in the room took a piece of paper and stuck it in a candle on the table and started wafting smoke around the room until the whole room just filled up with fumes, and he started coughing and spluttering and saying, "What the devil's going on?" So he turns, and then just at that moment, he hears the "Gardez-loo," and they all tip their slot buckets out at 9 o'clock onto the streets outside. And then in the night sweepers come along and take it all down to the river where it festers in a big swamp. So he wrote back in this letter that he racked his brains, and he said he couldn't think of a solution to this problem. He said, "Anything so expensive as a conveyance down from the uppermost floor could never be agreed upon, nor could there be made within the building any receiver suitable to such numbers of people." A receiver, he means a toilet. But I've lived in Edinburgh, and it's a lovely city. And you can see in this picture all of the sewage pipes going down the sides of buildings. It was possible, right? He just couldn't imagine that it was possible. But in the 1800s, in particular, there was campaigns for sanitation and proper sewerage because of epidemic diseases like cholera were becoming widespread in overcrowded cities. And so this is a picture of them digging up Fleet Street in London to build the sewers. It was a huge infrastructure project that the state embarked upon at the time. Hugely expensive, huge manpower, hugely disruptive to the lives of people, but they did it because it was what was required. Again, another example. This is, So this is a picture from the Times about the crisis of horse manure in the streets. And so in the Times in 1894, in 50 years, every street in London will be buried under 9 feet of manure. This was a real concern amongst town planners at the time. They just didn't know what to do with all of the fact that so many people, cities were getting bigger, you had to use horse travel to get around more and more, and so more and more people were living in cities, you had more and more horses, and what did you do with all the manure? The first international meeting of town planners in New York happened around that time. That was the top thing on their agenda. Little did they know that around the corner, so this is New York in 1900, down Main Street. All of these are horse-drawn carriages, pretty much. So this is 13 years later, same street, automobiles. I'm not saying that's exactly what we want, but the point is that they couldn't imagine that was about to come, right? And then when it did come, it came really quickly. So again, we could be looking outside this window here in 13 years' time, and they would all be electric buses and cars, and people are traveling on bikes, right? It could be. There's no reason it can't be. Another one from my own personal life is around the smoking ban and when that was brought in. So when I had my 18th birthday, I went to the pub to have a beer. And that was supposedly a nice thing to do and something to celebrate. But I was asthmatic. And I went in to have my birthday pint, and I couldn't even finish it because I started having an asthma attack. Again, at the time, most people felt, well, that's just normal. That's what pubs are like. That's how it's always going to be. But it's not, right? And we've now had the ban, and it's great, and I can go to the pub and have a pint with my friends and do so. So, another one again is around gay marriage. And I was chatting with my parents the other day, and they were saying, Aaron, when I was your age, I don't think that I'd have ever thought that this was possible. But it is. It's possible here. It's possible now in Ireland. It's possible in the United States. Things change. It's remarkable, but they do. And so the real thing that we have to be conscious of here is that when you're stuck in a moment and you've just, that's the way it's always been, trying to put your head in a point of view to imagine a future where that isn't so can be really difficult. And we have to look back at these examples to show us that change is possible. And perhaps one of the most remarkable changes, of course, is the end of apartheid in South Africa, which Nelson Mandela said on his release from Robben Island that it always seems impossible until it's done. So with that in mind, I'm now going to take us 30 years into the future and look back from a future where we have solved these problems, we have managed to transition to a low-carbon economy, and ask the question, how was it that we managed to get there? So, if you'll help me, and if you'll indulge me, we're going to get into this time machine, and I need you to make this sound, okay? So it's woo, okay? All right, are you ready? Okay, go. Woo! All right, and we're there, okay? We're 30 years in the future. And someone's just asked you the question, how is it that we managed to go from that fossil fuel economy and this trajectory towards 4 degrees of warming and avoid that? How is it we managed to avoid this problem? So yeah, we're living in this kind of safe and just space for society where we're living within all the planetary boundaries, but we're also providing for everybody's basic needs. And here we are, okay? So one of the things that helped us get there was the fact that the cost of producing renewable energy just kept on plummeting and plummeting. The scientists and technologists did their thing, and the engineers worked hard and found new and exciting and unforeseen ways to bring down the cost of the deployment of renewable energy. So the cost of solar power fell 80% in just 4 years and continued to drop faster and faster. Cost of producing batteries for electric vehicles and other energy storage continued to fall along similar curves. And the cost of wind fell a third in just 4 years as well. And it carried on that way, and so that between, for example, if we just took 2 dates of 2016 and 2018, the price of offshore wind halved in the UK in that time. And because the rate of deployment, because the cost kept on coming down, the rate of deployments could keep going up and up and up, faster than anyone had predicted. And so in the same way as scientists had underestimated the rate at which some of the climate impacts were going to occur, they also dramatically underestimated the rate in which renewable energy could be deployed. And so we saw, for example, that the projections for solar panel power continued year after year to underestimate what was really achieved. And the same was true for wind. And there came a tipping point, one of these crucial tipping points, whereby the cost of producing clean energy matched that of producing dirty energy from coal. At that point, it no longer made sense to continue to invest in building more coal power stations because you could build clean energy for the same price. And it didn't take much longer until it actually became a lot cheaper to build those clean alternatives. And that happened around the 2020s. It happened a bit sooner than that in some countries, China, and in some of the tropical countries where they have a lot of solar energy. But there was another tipping point, much more important, that was just around the corner. And by 2030, we reached that tipping point whereby the cost of producing renewable energy was actually much cheaper than keeping existing fossil fuel infrastructure open. And at that point, it became sensible to shutter all of the existing fossil fuel infrastructure and build clean alternatives instead. So that was the second tipping point. But what brought that tipping point forward in time was the fact that communities had organized to increase the rate of deployment of all of these technologies as fast as they possibly could. And that helped bring down the cost of those curves. And so communities organized to put solar panels on their local council buildings and their schools and their hospitals. And they lobbied politicians to continue to maintain subsidies for those technologies so that they could be rolled out more quickly. And they formed community energy projects. And those brought in investments and returns that benefited those local communities. And trade unions helped organize to demand more green jobs and showed that investing in these technologies was bringing new and high-skilled jobs to those areas. And so whilst back in 2008, the government of Tony Blair and Gordon Brown had been projecting on building new coal power stations in the United Kingdom, which provoked groups like Greenpeace to climb Kingsnorth Power Station and paint on it. So they went to court and they were acquitted for that. But in 2018, that power station was demolished because the UK had announced by that point, just 10 years afterwards, that they were going to phase out all coal power stations by 2025. And then the French went one step faster than us and said that they would do it by 2021. Another thing that accelerated which actually pushed up the cost of the fossil fuel energy was the rapidly expanding fossil fuel divestment campaign, where people organized in their communities, in their universities, or in their churches, or again to their local councils, and asked them to move their money away from these fossil fuel companies and instead invest in clean alternatives. And they could do it themselves with their own bank accounts, and they'd come together in groups and they'd get all their neighbors to join in, and they'd all switch their investments away from dirty energy and into clean energy instead. They would organize in their churches and in their trade union branches to do this. And ultimately, whole governments would start moving their money away from investments in these industries. And so Norway was one of the first to do this, but Ireland quickly followed them, and then it spread around the world. And brave activists and campaigners went and shut down fossil fuel extraction infrastructure, driving up the cost of production. Here in Germany, in the largest open-cast coal mines with huge machines that were cannibalizing the earth. And scientists went and joined them. And so, for example, the climate scientist I mentioned at the beginning of the presentation, James Hansen, who is director of NASA's Climate Science Research Unit, here is being arrested outside the White House trying to stop the building of a pipeline in the United States. And indigenous tribes and communities around the world fought to protect their sacred lands and organized and used their legal rights to prevent the building of fossil fuel infrastructure. And their allies supported them in fundraising for legal cases and the like. And in the UK, grandmothers organized to prevent fracking from happening in their local communities. And they resolutely, for years and years and years, prevented that going ahead until the whole scheme was scrapped. And at that point, this carbon bubble that I was telling you about popped. And these companies, investors couldn't quickly enough get their money out of the fossil fuel companies and into somewhere else, because they had confidence in those industries, and they could see that they were overvalued and that they didn't have a future. And so whilst Peabody, one of the largest coal companies in the world, was saying as recently as 2010 that coal's best days are ahead, they were bankrupt by 2015. Yay! The first of many. And people started changing their diets in large numbers. The UK remarkably saw huge numbers of people switching to vegan food in very short periods of time. And even whole governments started changing the amount of meat that could be produced. And so China planned as early as 2017, made an announcement that it was going to reduce its meat intake in that country by half. And that also had all sorts of positive side effects, because of course, not only was it lower in terms of its environmental impact, it was also much healthier for us. And so people with public health improved dramatically. To go alongside of that, there was a revolution in farming throughout the country, throughout the world, where agricultural, ecological models of farming, which were far more productive, started being deployed around the world. And agroforestry was developed, whereby we could farm amongst the trees, and they help bring and absorb carbon at the same time as producing food, and make us more resilient to climate impacts as well. And so it became very apparent very quickly that we did not need fertilizers and pesticides to feed the world, and that we could find alternatives. And that allowed us to then restore huge areas that had been degraded and return them to healthy environmental status. Transport systems changed dramatically as well. And so, yes, there were lots more electric vehicles. And that was partly because governments started announcing that they were going to phase out entirely fossil fuel cars and combustion engines. So the UK announced that quite early on, that they were going to ban petrol and diesel engines by 2040. But people said that wasn't good enough. And so Scotland said they were going to do it by 2032. And they said, that's not good enough. So India said that they would do it by 2030 for all their vehicles. And quite rightly, Norway, as a developed country, said, well, if the developing nation can do it by then, we can do it by 2025. And then we were really talking. And by 2025, half the world's bus fleet was electric because it was so much cheaper to run, and the clean air benefits of that were instantly benefited the local health services, and again, people were fitter, instances of asthma and respiratory illness went down dramatically. Copenhagen led the world in the transition to active travel infrastructure and proper investment in the bike lanes that people wanted to get around the city. Paris banned all of the cars on its left bank along the Seine. I mean, can you imagine that? They used to drive vehicles along the main pathways in Paris. But as soon, this is how we imagine it today, right? And so that happened in 2017, before, of course, it was turned into the lovely park that is there today. And of course, all the while, the impacts of climate change were getting worse and more apparent to everyone. Every day on the news, we heard about the floods and the storms and the wildfires and the heat waves that were killing people around the world. And as people saw those impacts, they became more concerned and more determined to take faster and greater action. And when they felt that the media were not telling the truth and not communicating the urgency properly, they would send messages to them over social media saying, end climate silence, connect the dots. They would lobby and organise and go outside the BBC and other media-producing centres and demand that they tell the truth. And that started having an effect where news broadcasts would talk about the emergency, where people were informed of the facts, and where deniers and skeptics were kept off the airways and not allowed to misinform the public. And of course, people organised politically to challenge their governance systems. And so there were mass rallies and marches. There were mass lobbies of politicians where MPs and councillors would be bombarded by letters and public meetings. And towns would declare climate emergencies. And again, in very short periods of time, this spread where dozens and then hundreds of towns, first in the UK and then around the world, declared an emergency. And that put pressure on national governments to do the same. And with those emergencies declared, we could develop plans and allocate resources to where they needed to go. And where governments refused to implement these changes, the citizens crowdfunded and then sued those governments so that they had to do it, as they did in the Netherlands and then in other countries around the world. And artists and thinkers and writers started pouring themselves into imagining different futures, futures that had been decimated by climate change, but also futures in which we addressed the problem and helped us imagine where we needed to get to. They questioned why it was that we hadn't been telling these stories to each other. And they used music, and they used theatre, and even celebrities used their status in society to, when they had an Oscar Prize, use their speech to talk not about themselves or the films, but about climate change and the crisis that we were in. And by doing that, we not only connected our intellectual understanding of this problem, but we did it with our own emotional understandings of these problems in new and creative ways. And that allowed us to then picture and build an imaginary future that we could then build. And where the fossil fuel industry tried to cling on and hold cultural spaces in order to greenwash itself and buy social influence and buy social license, performers would go and say, We don't want your sponsorship in our museums, in our galleries, or in our theatres. We don't want you having a role in our societies anymore. And so it took a mass mobilisation and a mass civil movement, the likes of which has always been required to create drastic social change. Whether or not it was the votes for women, or the civil rights movement, or the gay liberation movement, or of course the early environmental movement. They all took that to force the issues up the agenda and make them enough focus that we actually began to address them.
In the years leading up to that first Earth Day, many Americans became concerned about what they saw as unchecked air and water pollution and the destruction of forests and other ecosystems. Dennis Hayes was the first Earth Day national coordinator.
In Los Angeles, the estimates were that for simply breathing, it was the equivalent of smoking 2 packs of cigarettes a day. We had rivers that were catching on fire, lakes that were dying. The American national emblem, the bald eagle, was on the verge of extinction, and on and on.
The growing anti-war movement of the late 1960s also contributed to the surge in environmental activism. As Earth Day approached, support for it spread. On April 22nd, 1 in every 10 Americans took part in rallies, concerts, educational programs, and cleanup projects.
It was to raise a set of issues, to tie them all together into one fabric, so that the people who were fighting against pesticides and the people who were fighting to stop freeways cutting through their neighborhoods, or fighting against air pollution, or fighting to preserve a wetland, would realize that they had common values.
The public outcry on that first Earth Day led to political action. Congress passed new laws for clean air, water, and endangered species, and created the U.S. Environmental Protection Agency.
And so when the first international climate rebellion happened, it was closer to maybe 2 in 10, 1 in 5 people were involved. And that sustained pressure that happened again and again in wave after wave allowed this issue to remain as the #1 priority for all of the world's leaders. And as the great environmentalist Bill McKibben, whose statue stands in Parliament Square to this day, said, climate change is the single biggest thing humans have ever done on this planet. And the only thing that needs to be bigger is our movement to stop it. And so it was. And so because climate change is all of these things, it took everybody from all of those different parts of society with all of those different interests to come together to take action. Whether or not that was workers fighting for green jobs, or environmentalists and nature lovers campaigning to protect the birds, or doctors campaigning for public health, or mothers and grandmothers caring for their children, or Christians or Muslims campaigning to protect creation, and of course young people fighting to protect their futures. It took everyone, and that is what it meant to have courage in the climate crisis. That was what it meant to keep going until we got to where we needed to get to. Because it was right to save humanity. And it is wrong to pollute the earth. And that it was right to give hope to future generations. So, if you ask me, will we change? I can't promise you that. In fact, sometimes I don't think we will. But I know that I've got to keep trying. Because if there is any possibility that we can turn this around, then I have got to be part of that solution. And my question to you is, will you join me?
Yes.
Thank you.